Okay, so for the introduction, so the major impacts of globalization of nutrient cycling and hydrology have made it more difficult to manage the water quality in urban lakes. So precipitations, also referred to as rainfall, serve as a location main sources of water. Excesses of insufficient rainfall will lead to both drought and flooding. Malaysia, a country with heavy annual rainfall, is considering installing a rainwater collection system in order to address flooding and water scarcity. Rainwater collection has gained international interest recently as a sustainable home water supply. So for the case study location, we choose Kapit Sarawak as the research case location for Malaysia's flooding issue. So we have chosen the rainfall station at Rumah Gual Kapitan and Naga Sebatu. For the water level at the Sungai Rajang station, Kapit is a town and the administrative hub of Kapit district situated in Sarawak, Malaysia, on the southern bank of the Rajang River. So here it is also the location for our case study location.
Hi, my name is Nor Ashra and I would like to present about the methodology that we use. First, we use Google Earth Pro, which is a shareware program that lets everyone view, evaluate, overlay and create geographic data for learners who want to start with simpler techniques and technologies but want to learn more about GIS, which is a Geographic Information Systems. This easily navigable resource is often a nice intermediate. Google Earth Pro may be used to locate location, upload and download geospatial data in its native interoperable file format and see its extremely very high resolution setting. Next is rainfall and water level location study. By visiting the Department of Irrigation and Drainage website, we were able to pick a better location for our research. Sarawak was one of the states examined, and the area was picked since it was well known. The location of the rainfall data are Kapit Town, Song B and Nanga Merit. Our water level information pertains to Kapit Town's Sungai Rajang River. All of these stations may be found in Kapit District's main city, which is located on the south bank of the Rajang River in Kapit Division, Sarawak, Malaysia. For collecting data, we use three methods, which is Thiessen polygon method, isohydral method, and arithmetic mean method. For Thiessen polygon method, the Thiessen approach is the second way to figure out the average precipitation. This approach is a typical for weighting local rainfall gold readings. The weighted mean technique is yet another name for this approach because employs a predetermined region. This approach has the benefits of being quick to deploy for a spread of storms. All gods and around the basin are taken into account for this strategy. A divisor of two perpendiculars is drawn between each rain gods using this technique. There are 4 steps to make this method. First, we connect each precipitation station with straight line. Second, construct a perpendicular bisector of the connecting lines and form polygon with these bisectors. Third, determine the area of the polygon, and the last one is we calculate average precipitation using the formula. The second method is the isohydral method, which is one of the more accurate approach, but using it takes expertise and understanding. By drawing a similar precipitation line across the district, this technique may be used to determine the mean annual precipitation. The isohydral method displays precipitation values at chosen station on a suitable base map. Catchment interpolation base. First, find the rain god and record the total rainfall reading. Second, interpolation between god is performed and rainfall amounts are plotted at time interval. And the last one is isohydral method. Isohydral is formed by interpolating the identical depth. For the last method, we use arithmetic mean method. This is the simplest way, which involves averaging out of all rainfall amounts. The average or mean of it is what is seen. If the placement of each station is balanced, this strategy performs effectively. To calculate sum all the data that was collected and divide the result by the total number of elements in the set. The middle number can be used as the arithmetic mean for an equally distributed integer. Next, based on the volume and distribution of the data, multiple approaches are used to derive the arithmetic mean. The station's measurement of rainfall must be reliable. This is a hydrograph. First is a song B, and then Kapit Town, and for the last one is Nangamari.
Next is data presentation. So we collected the rainfall data and water level data from October year of 2022.
My name is Muhammad Din Shekal, and I'm going to present about our analysis and result. Firstly, our group, when doing the analysis, we gathered the rainfall data from three locations, which is Songbi, Kapit Town, and Nangamari. The data is gathered and calculation of the average precipitation depth recorded in our target area done by using three methods, which is arithmetic method, T-cell method, and isoheater method. As you can see on the slide here, you can see the way we calculated our data. We gathered the data of rainfall, and then we used the arithmetic mean method. Now here we can see the water level data that we get from catchment region. We make the river hydrographs is take into account both geographical and temporal fluctuation in water supply, storage, and migration activity. As a result, distinct logical regimes in certain catchment region may be represented by the hydrograph. And as we can see here, we got the formula to calculate the hydrographs up there, and we have the table about the data of the water level for 4 weeks from week 1 to week 4. Now we can see how we count the cross-section profile of the three location we choose for the river, and we use the rational method. You can see the formula up there, and this is our process or calculation that we present on the slide right here. And now for the hydrograph and unit hydrograph, we can see a hydrograph in a river, canal, or under conduit carrying a flow is a graph that shows the rate of flow or discharge versus time after a specific point. Typically, the flow rate is expressed as cubic per feet second or cubic meter per second. It could also be referring to a graph showing how much water enters a specific sewage network area or outfall. When designing sewage system, particularly combined sewers and surface water sewage system graph and are often employed.
This is discussion part. The climate change knowledge portal describes Malaysia as having a tropical climate with an average annual temperature of 25.4 degrees Celsius. The monthly average temperature ranged from 24.9 degrees Celsius in January to 25.9 degrees Celsius in May, with very minor variations from month to month. Since 3085.5 millimeter falls on average each year, rainfall is likewise continuously high in mm. Throughout the year, the average monthly precipitation is likewise quite constant, averaging 200 mm in June and July, and 300 mm in November and December. At last, we also get the catchment area for these three methods by using Google Earth Pro. T-sim polygon method is 13.65 mm. Isotile method is 13 mm. Arithmetic mean method is 13.167 mm. Lastly, conclusion. This study concludes by contrasting and comparing several methods for figuring out runoff output for drainage design. Before constructing a drainage system, a hydraulic study of the amount and length of precipitation, the peak runoff rate, and the temporal distribution of runoff from a certain catchment area is necessary. Numerous hydraulic techniques can be used to determine peak flows from a catchment region, and no single technique is suitable for every catchment area. The unit hydrograph technique is not frequently used due to its limitation, which include the cost of obtaining runoff data for a given catchment and the lack of runoff data for at least 25 years. Even though it provided the most accurate peak flow estimate of all the approaches studied. In the end, Even the data that we gathered and examined has some mistakes and discrepancy in it. With the assistance of our instructor and the other group members who put in a lot of effort to finish this assignment, we are able to fix the mistakes. Since the project is web-based, we can open the data from several websites and applications. For instance, Google Map Probe is quite useful for finishing the cross-section component, determining the river's width and characteristic the surroundings of the monument. Thank you.